invite Professor K. Jianshu, the Vice President of ISSMG Asia, onto the stage. Welcome, sir, and over to you. I would request the chair and co-chair to take over.
I welcome you all for this keynote lecture 4 of Professor Chung-Sik Yu, President, Fed IGS. Oh, sorry. It is a keynote lecture 5, Professor K. Jianshu, ISSMG, Vice President Asia. Topic of the lecture is advances of trenchless technology for infrastructures. I invite Professor K. Jianshu on the stage for the keynote lecture.
Thank you. Thank you, Chairman. Good afternoon. It's my pleasure to deliver this lecture. As you can see, the title of my presentation is Advances of Technologies for Underground Infrastructure. So you can see from this slide, I'm going to introduce this technology a little bit before I go into the details about some of the research development for the past 15 to 20 years. Two major directions. One is trenches new installation method, and the other one is trenches rehabilitation method, CIPP. Give you some idea about the trenches technology. What is the trenches technology? It means that we do some underground work without cut the open ditch. So by this way, we can reduce the impact to the environment, and also that can, for the current concerns in the world, we can like reduce the carbon dioxide emission, and also it can reduce the energy consumption. So that's the benefit by doing this these trenches constructions. So the background of this development of this technology is that you can see for this kind of underground condition, there's no way we can do for either the new installation or rehabilitation by doing the open cut. So that's the background. So in other words, based on this kind of a condition, new trenches technology are more demanding in the big cities, especially the mega cities with aged old pipelines. And as I said, the problem of the open cut, including the traffic congestion, pavement damage, and indirect business loss, and also CO2 emission. So those concerns are more and more important nowadays. So that's why trenches technology are more and more attractive than before. So according to the definition given by the International Society of Trenches Technology, actually there are three major categories of this technology. The first one is on the top, called the condition assessment, including the exploration of the existing pipelines or underground structures. I think most of the geotechnical engineers are quite familiar with that. We can use a geophysical exploration to explore the underground conditions. That's the one of the subcategory on the left-hand side. But in the right-hand side, for the age pipeline, we have to know the condition of the existing pipeline. So sometimes we have to do some internal inspection. The most common method, I think as you may know, could be the CCTV inspection. But actually there are other technologies under development. As Professor Yo said this morning, we could use UAV. UAV can be applied for the internal inspection. And also we could use the radar detection in the pipeline. Also, recently, due to the climate change, we have extreme rainfall. That also could cause some problems. You can see from the news, we have more and more sinkhole, surface collapse happen. The challenge now is how can we use the method to explore the potential location of the sinkhole and surface collapse, especially some of those sinkhole and surface collapse could be due to the leaking pipelines or damaged connectors of the pipelines. So this is another subcategory of the condition assessment. Right upper part of this diagram. And for the lower part, lower left is the technologies we can apply for a new installation. I think we might be familiar with technology called pipe jacking, shear tunneling, directional drilling. That's the most common, most popular method. Actually, there are more than those three methods that we could apply. Each method has its advantages and disadvantages. So if you are interested in this, you can check the ISCT website. We have a new version of the guideline, technical guideline. We have maybe more than 20 methods you could apply for the new installation. On the right lower part is the method we can apply for the rehabilitation. We have a method that can be used to local repairing, and also we could just replace the H pipeline by install a new one. In other words, the old pipeline will be abandoned. The third subcategory is we call rehabilitation. Means that we still keep some function of the H pipeline, but we install a liner to improve its function. So that's the method. Okay, so for the sake of time, I will skip this, focusing on the two methods. I would like to show you that we have done some research. The first one is the rehabilitation, CIPP. CIPP is the abbreviation of a cure-in-place pipe. We install a liner inside the H pipeline to improve its function, and the lifetime can be extended for 30 or 50 years more again. The shape of the pipe can be different geometries. Left-hand side is the image for the liner. The liner will be marinated with the resin and hardened by the chemical reaction. It could be cured by heat or light, and then the liner become a hot pipe inside the pipe. You can see from the upper right image. Then the pipeline has reborn. So, so the application of the CIPP can be used for the pipe experience the deformation, corrosion, and disengaged connector, etc. The shape can be quite different. The research we did is try to understand what are the major control factors for the performance of the CIPP recap pipeline. If we think about the problem itself, it's more like a soil pipe interaction, very similar to the simulation of tunneling in soil mass or rock mass. The only difference for this model is that we have one more layer, thin layer of liner inside the existing pipeline. So we have two interfaces instead of one interface. So one interface is between the pipeline and the soil mass. The other interface is between the CIPP liner and the pipeline. So two interfaces. We have to determine the parameters, the mechanical properties of those interfaces in order to have a meaningful simulation. Okay, that's the important thing. Also, we have to determine the problem. And the image in the center, you can see the simulation of the cavity for the pipeline, corroded pipeline. So the geometry can be straight line, can be curved. So those are the table, the parameters we applied. You can see that in this table. And also we simulate the problem with the different geometries. These two figures shows the stress distribution before and after the rehabilitation. You can see that after we install the CIPP liner and we apply the internal pressure, you can see the stress concentration can be relieved. So in other words, it also shows the performance of the CIPP rehabilitation. So these two figures shows that the stress is at the center of the cavity with the CIPP rehabilitation, but with different internal pressure. The horizontal axis shows the internal pressure because the pipeline can go back to operation with CIPP rehabilitation. So you can see that if we increase the internal pressure, the performance is more significant. In other words, the stress concentration will be reduced more significantly. So these are the performance for the cases with the curved alignment. So the cavity can be in the inner side of the curve or the outer side of the curve. For both cases, you can see that the performance are similar to the straight line case. But you can see the comparison, I mean, those four figures in one column means the different depth of the corrosion. So these two figures show the case. Also is a comparison based on the previous figure. It shows the performance as well. These figures shows the comparison with a different deformability of the liner. In other words, the CIPP liner can have a different designed deformability. The results shows that the harder the liner, the better the performance. You can see the harder one have a less stress concentration. Okay, this is a comparison between cases with the cavity top of the pipe and the side wall of the pipe. Also, the performance slightly different, but also I think the performance of the CIPP is obvious. And these two figures could be the most interesting finding for this series of simulation. You can see this is the comparison for the cases with different thicknesses of the liner. You can see they are two lines on the lower side. They are very close to each other. Actually, those two cases are the case with a different thickness of the liner. You can see they are almost the same. The also means that the case with a thickness of 10 millimeter is not necessary. 5 millimeter is enough. So in other words, by doing the design analysis, we can see the necessary thickness of the liner. Generally, in practice, the thickness actually was suggested by the supplier, material supplier, based on their experience. But as a geotechnical engineer, we can double check whether it's over-designed or under-designed by using the analysis tools. So this is the beauty of this analysis. Okay, this is the first part for, I think, for the application of the trenches technology for the rehabilitation. We also did some analysis for the rehabilitation of the connector, disengaged connectors. Also, we consider different scenarios. So, if you are interested in this, I can share with you some of our published papers. So this is the second part. The third part is a new installation. I'm going to talk about the series of analysis we have done for the pipe jacking. As we know that for the pipe jacking project, the most important thing could be jacking force. If the jacking force is not enough, maybe the pipeline cannot be jacked to the target location. But if the jacking force is too large, maybe that will damage the connector or the pipeline itself. So determining the jacking force could be very difficult. Generally, we have some empirical formulas given by different scientists or some guidelines or standard. I think you can find that from the guidelines from different countries, but still, most of those formulas are the empirical one. Some guidelines are very detailed. They can classify the pipe jacking into different the type of jacking machine, different diameter, different geomaterial, and you apply different formulas. But still, according to our case review, we found that there's still some discrepancies. So what we are trying to do is that we try to find a better way or review or compare the empirical formulas that we can use. This is the purpose of this study. We adopted one case in Taiwan area, which could be very challenging because most of the formulas are not applicable. So the geology for these cases in west side of Taiwan, we have a lot of alluvial formation, but we have a large size gravel like this. The largest diameter can be up to 1.5 meter. Very big. So it's almost the size of the pipe jacking machine. So very challenging. So we try to we try to find the control factors, important factors for the pipe jacking project first. We developed some geostatistics model to predict the probability we encounter the large size gravel in order to help the manufacturer of the pipe jacking machine to improve their cutter head. You can see this is the difficulties or the problems we encounter. You can see this cutter abrased seriously. That will damage the since this cutter doesn't work anymore, so the cutter head itself could be damaged further. So this is one of the major problems, over operation. And the second problem we could encounter is that the gravel will trapped in the annular space and stuck the pipe stream behind the pipe jacking machine. And also it could damage the connectors. This is the problem we have. So, so what we did first is try to collect the samples from the lunch and arrival shaft, do some sieving analysis, and we use some just this model to see what are the large, what are the geometry we could encounter during the tracking operation. So some mathematical model can be used, and we also find, we also apply some model transitional probability theory to predict the largest gravel between the lunch shaft and arrival shaft. So this is the model. This is the model we developed. You can see we separate the size to three different sizes. Try to simulate the geology by just this model. Okay, this is the second part of the development, and then we can see we can compare the advancing rate with the results of the statistical analysis. So then let's talk about the since the gravel can be loosened by the excavation, it can stuck in the annular between the pipe jacking machine and the soil mass. So the behavior of the overcut and the stuck of the pipe stream also further studied. So we consider different scenarios, including the overcut in different area, and also you can see this is the geometry we considered, overcut in different circumferential range, also the stack of the gravel in different locations to see what will be the consequences of those different scenarios, and try to improve that by backfill or by inject the lubricant, change the material property of the interfaces, and also change the material property of the overcut and annular space. So that's the analysis we did. So based on this finding, I think the major finding is that backfill will be helpful for the stress distribution, the stress field, and also the lubrication to the interface is very critical, very important. Totally stuck should be avoided. So injection of lubrication is essential for smooth operation. This is finding the stress distribution, and also the results for the scenarios with different condition of the stock, location of the stock, you can see. So also, similarly, we did a similar analysis for curved pipe jacking. So again, we simulate the cases with the different scenarios of overcut and different locations of stock. most of them are stress analysis and comparison. Okay, for the jacking force prediction, as I mentioned previously, the most common way to predict the jacking force is to use the empirical formula. But we found that the formula can be quite different, especially when you inject the pipeline longer and longer. The discrepancy between the jacking force predicted by different empirical formula will be large. So it's quite uncertain based on this prediction. So what we did is we tried to use the method called displacement control method. Because when we simulate the pipe jacking, we apply the force behind the jacking machine and to push the pipeline ahead. Although we put in place the interface property with a suitable frictional coefficient, but still, it's difficult to determine the jacking force. Sometimes it's pushed too far, sometimes it's pushed not enough. So the method we apply here is we call it displacement control method. You may remember that for the numerical model, we can assume that the pipeline move forward to a certain distance. So we manually or artificially move the pipeline ahead to the distance we assign. And then we integrate the forces, the stresses, we integrate the stresses behind the element represent the pipe jacking machine. So, so we can determine the jacking force based on the integration of the stresses. So this is the idea. So you can see the distribution of the stresses behind the pipe string, and we integrate that to determine the jacking force. So also different scenarios. So you can see this is a comparison of the results. You can see that those straight lines are predicted by the empirical formula. They are either overestimate or sometimes in between, but it's not very close to the real case. So here we have two real cases. You can see that by doing this displacement control simulation, we can properly simulate the total jacking force a better way. That's the finding. We also applied the same approach for another case. Couldn't go back. This is another case with a smaller diameter. Also get the similar results. So in other words, displacement control estimation of the jacking force is quite promising. I think that's my presentation. Thank you for your attention.
Hello. Professor Ken Soong narrated very good way his content of the lecture. You know, the trenchless technology is very essential in busiest area of the city. Particularly the geotechnical condition, its prediction is very essential for the trenchless technology. One more thing is the study of the behavior of the overcut, and particularly the jacking force estimation in curved pipe is very important. Particularly, he presented the case analysis also with respect to the trench technology. and his way of presentation for the trenchless technology will be highly useful to the present practice in the geotechnical field. I thank you, Professor Seung.
So we have our second keynote speaker of this session, Professor Ralph. He will be talking on Pile Raft Foundation. So we welcome Professor Ralph.
Gentlemen, dear colleagues and friends, the most important information is I have got 30 minutes from now on. Looking on the original schedule, in 8 minutes I have to finish. The problem starts already that there is no slide. Who is managing that? Over there is nobody sitting. Can start, please, my presentation. The wonderful young people which support us here. That fits quite good to the topic of my presentation, which is the history. The history and the geotechnical basis and the scientific basis, for sure, of the Combined Piled Raft Foundation. And history means something old, which might doesn't work. And I can tell you, to speak about the history of the Combined Piled Raft Foundation needs about 2 to 3 hours, because the history is starting in 1970 or something like that, more than 50 years ago. So if you need the stick again, I have it here. Perhaps you can stop, please, the watch with 30 minutes. Apologize for that. I never had thought that that problem would arise at that wonderful organized conference. But shit happens, and I think it's not a real difficult problem. I see it already on the screen, and you all also. Now, so I mentioned already the title, the history and the geotechnical basis, and that means for sure the scientific basis of the Combined Piled Raft Foundation. Short form is CPRF. And I added the title with respect to the undertitle or the additional title of the conference with the name or the word GeoVadis. So I ask GeoVadis CPRF in the future. Let us look to the history you have seen in the first slide. My home city, Frankfurt. The front there is the European Central Bank, and in the background the banking center. Frankfurt, we have the following ground situation. On the top, after 4 to 6 meters quaternary gravel and sand, we have the so-called Frankfurt clay. The stiffness is increasing with steps, with values of about 15 to about 50 meganewton per square meter. Under Frankfurt clay, we have limestone, quite stiff material with a stiffness of more than 250 meganewton per square meter. That is more or less a rocky layer. That means ideal for geotechnical experts and consultants. At each position in Frankfurt, we have other and changing ground conditions. What is the problem in my home city, Frankfurt? You see the problem a little bit from the curves on the right-hand side. There is plotted versus epsilon 1, the vertical strain, the stresses, or the deviator stresses, sigma 1 minus sigma 3. And you see a lot of different curves with relatively normal, respectively high stiffnesses. And at the bottom of these curves in red, you see the load settlement curve or the stress-strain relationship of Frankfurt clay. And from this situation, from this weakness of Frankfurt clay, you can imagine that the main problem which we have in Frankfurt are the total settlements, or especially of the high-rise buildings. And if you have great settlements, great total settlements, the next problem are the differential settlements. So it's necessary to find a technology to the reduction of settlements in the relatively soft Frankfurt clay. Some examples, and we understand that as geotechnical engineers, as large-scale tests, in parentheses for sure. In the first generation of the Frankfurt high-rise buildings were founded on shallow foundations on big rafts. The reason was it was totally impossible to create board piles in Frankfurt clay. There were no machines available in the 1970s and in the early 1980s. So we had extremely high settlements, for example, for the Marriott Hotel with a value of 34 centimeter. 34 centimeter. That is normally not tolerable, I would say, for a building which is more or less used as hotel and as office center. And because of the differential settlements, this was necessary to install hydraulic pressure cells in the level about 20-25 stores in order to have a horizontal basis for the upper part of the building with a hotel sector with a very, very rigid construction made of concrete cells. And these concrete cells would never allow this deflection and the differential settlements which occur there. Another examples are the twin towers of the German bank, the Deutsche Bank. You see the left and the right tower. The left tower settled 22 centimeters, 22, not a mistake in the presentation, and the right tower 10 centimeters. Both towers are standing on one big raft, 80 meter long, 60 meters wide, 4 meters thick, but they had a differential settlements of 12 centimeters. The reason is the towers have not the correct right weight. The left tower is a little bit more heavy, and the soil under the left tower is obviously weaker. That led to enormous problems and to the difficulty to create corrections by, for example, by hydraulic pressure cells at the area when we have these smaller areas which are colored blue in that drawing. So the problem in that time was that it was, and I think that is worldwide more or less comparable, our duty as geotechnical engineers to design either a shallow foundation or a deep foundation. It was not allowed in German codes and European codes, and I think even in India here, to mix these types of foundations, a deep foundation with a shallow foundation. And you see this old-fashioned norm is plotted on the left-hand side, comes from the year 1976. Meanwhile, these technical rules are updated, that it is indeed allowed, even by the German standards and the European standards, to mix these types of foundations and to combine it. And from that, the name is derived, combined piled raft foundation. And the best example for this mixture is India. In India, we have indeed a wonderful technical standards, the so-called Indian standard with the number IS 19117, where the rules for the design and the application of combined pile raft foundations as a code of practice are available. So the old-fashioned you can forget, and it is now given by this standard which I mentioned currently. Combined pile raft foundation has a lot of advantages and objectives, reduction of settlement and tilting, increase of bearing capacity of a shallow foundation, and. To make a long story short, combined pile raft foundation is at least a special form of soil improvement technology. You put piles in addition to the foundation system and create at least stiffness, and with a great advantage, you transfer loads from the level of the foundation in deeper areas where mostly stiffness is increasing, like in my home city, Frankfurt. Now it doesn't proceed. Oh yeah, there it is. Short information about the methodology we work by carrying out at least the rules for the design of a combined pile raft foundation. And that is always the same. You know that from your own and personal experience. On the one hand side, the theoretical model that must be top and super without any mistakes, and the experimental research on the other hand side. And the most important thing are the measurements at the site. We understand at least each high-rise building has a big field test where we get the real information about the behavior of the construction. I can tell you an important story, which is not normal worldwide, as I learned from a lot of conferences. In Frankfurt, it is a duty given by the building authorities that all these high-rise buildings are controlled by a monitoring system until 5 years after construction, so that we have a real and very perfect information about the real behavior of high-rise buildings under the local conditions. I think that is worth to be learned as experience, how this philosophy of observational method is applied, and even authorities apply that because their knowledge is quite qualified in that special and complicated case. Certainly the constitutive law is an important detail, that it is correct, more or less is fitting to the real behavior, but with these lot of measurements we can control the quality of our calculations before and after the design and compare it with the behavior of the buildings. The most prominent and at least the first example of a high-rise building in Frankfurt built on a combined pile raft foundation is the high-rise building Messeturm with a height of 256 meters. If we would build it on a shallow foundation, we would get settlements of 40 centimeters. 40 centimeters. That we calculated on the basis of the examples that I showed you before, and you can imagine that is not acceptable. What to do? We applied the combined pile raft foundation. You see here the pile layout, and a lot of these piles are equipped with measurement devices. And here you see a typical result of the load transfer and the load distribution versus depth. The upper part, the upper 10 meters, there's more or less no skin friction mobilized, and that means there is no reduction of the pile load. And in the deeper part, we have very, very high skin friction with up to 150 kilonewton per square meter, which is for Frankfurt clay an enormous high value. And that is a result at least of this group effect, pile group effect, and the higher stiffness in the deeper area of Frankfurt clay. And knowing about these results, we could scale for sure our modeling of these combined pile raft foundations. In result, you have seen the slide, the 64 piles would mobilize maximum at a maximum load, ultimate load, 64 multiplied with 11.3 meganewton per pile, 725 meganewton. The building load, which has to be carried into the underground, is 1,570 meganewton. Simple question, who in the audience would give his signature under such a design and says it's okay? The piles are not fully necessary to carry the load safe into the underground. And for sure, what happens? We should not forget at least the load transfer via contact pressure directly under the raft. Nobody can avoid the contact pressure. It is there, that is physics pure. And so the sum of both, the contact pressure with a value of 845 meganewton and the pile capacity of in some more than 700 meganewton carries the load safe into the underground. That is a new thing, absolutely new, that it is allowed to use the piles up to the ultimate geotechnical capacity and load. I come to the question in the opening, GeoVadis combined pile raft foundation, and the idea is simple. Application of CPRFs not only for quite seldom high-rise buildings, but in a lot of cases where deep foundations are applied, and especially at bridge foundations. A lot of bridge foundations with a lot of pillars and abutments are available, and here a short example, 3 alternatives, shallow foundation, combined pile raft foundation in the middle, and a classical deep foundation in a deeper rock layer. Have a look on that, what happens. A shallow foundation settlement, you see the load settlement curve, to the right the load, and downwards the calculated settlement. The working load is 30 meganewton, a settlement of more than 10 centimeters, normally not acceptable for a bridge pier. Next solution is sometimes now it works, the combined pile raft foundation. You see only 6 piles, at least swimming in the loam and debris material. Settlement curve you see here, in total about 3 to 4 centimeters at working load. And what is interesting with the calculation, we can calculate the failure of a foundation. You see these nonlinear curves which characterize at least correctly the soil behavior. And at least the pile foundation with a settlement which is certainly very small, 1 to 2 centimeters, because of the high stiffness of the rock. What is important, the differences are here, the settlement differences of these 3 types of design. What is important are the costs, for sure. You see, CPRF, 6 piles, is 5 million Indian rand, and the pile foundation is 16 million Indian rand per 1 pillar. Normally a bridge has a lot of pillars, the metro lines, which are often founded on bridges and pillars, and so it makes sense to apply at least this type of foundation technology in the sense GeoVadis geotechnical engineering and GeoVadis CPRF. we save a lot of money, and it's without any risk. It's a soil improvement technology which at least helps to make the underground and the whole system stiffer than normally. The railway bridge in Frankfurt, as an example, you see the original design on the left-hand side, and on the right-hand side the optimization, which we designed in my office, and we saved about 47 million Indian rand, which that's to the effect that the German railway authorities are always looking what we think about the design, which comes from our colleagues in a conventional sense. Last example, back to high-rise buildings in Frankfurt, a current construction project example, a skyscraper, a central business tower with 151 stories. The project value about 50 billion Indian rand. See here, certainly we apply BIM and all these new wonderful technologies where you can at least visualize complicated situation in the underground and with the board piles and so on. And at least reality is shown in the another BIM construction. Certainly the calculation was done with variations of pile length and pile layout and pile diameter and that's what we see is the optimized solution. Here a photo from the current situation at the site, which is just under construction. Meanwhile, the high-rise building has a height of about 20 to 25 meters. So the CPRF is daily applied in my home city, Frankfurt, and I think meanwhile in a lot of cases out of Frankfurt and out of Germany. I hope on the application here in India, as you have this new technical standard. Okay, thanks for your kind attention.
Thank you so much, Professor. It's such a relevant topic for Indian scenario because a lot of urban constraints, weak soils are very much predominant. So we are also doing a lot of work on this. Thank you so much for completing on time. So we can have one question to our keynote speakers for each one, I think.
Thank you. Congratulations on your presentation. It was very clear. My name is Walter Paniagua. I come from Mexico City, and we use this kind of foundations very often. My question is, have you considered using a different friction pile element? We use several times slurry walls instead of piles. That develops a lot more of lateral friction and gives you more tight design. What do you think of that?
As I understood, you ask about the tool or numerical model which we apply. Is that correct? That's the question?
No, the question is, have you considered a slurry wall, a diaphragm wall? Instead of friction piles, a friction diaphragm wall.
The philosophy behind the design is the same. If it is round pile, or if it is A multiplied with B as a slurry element, the idea is in both cases that this foundation element must not carry the whole structural load. Which type is at least below the raft is more or less independent. The load flow for sure is a little bit different between a pile and a slurry element or slurry element, but that doesn't matter. We have such cases meanwhile in application.
Thank you.
So thank you so much. And since we have, I think, 5 minutes, we can have one more question. Okay. So with this, we will.
Thank you, sir. I request the chair and co-chair of this session to hand over a memento to Professor Katzenberg as a token of our appreciation. I request Professor K. Jian Shu to accept a memento as a token of appreciation from our end. Request Professor Neelima Satyam to do the honors. Ladies and gentlemen, now we are moving on to the panel discussion. Meanwhile, I request Dr. A.P. Singh to come forward to hand over a memento to Professor Shroff and Dr. Neelima Satyam. Request Professor A.P. Singh to hand over a memento to Professor Shroff and Dr. Neelima Satyam. Thank you, sir. We now move on to the panel discussion featuring the board members of FED IGS and the panel discussion on the topic Geo-Disaster Mitigation in the Face of Climate Change. I invite the moderator, Andrew McNamara, Secretary General of ISSMG. I also invite the panelists, Professor Chung Sik Yu, Dr. Mark Belaus, Professor Sekwon Jion, and Professor Vasilis Merinos, along with Dr. Samuel R. Allen. Thank you all. Over to the moderator.
Okay, thanks very much. Many of you may not even know of the existence of FedEx, but hopefully by the end of this session you will do so. We're going to have a little discussion session, and I'm going to ask Professor Chung Sik Yu to just start by giving you an introduction to FedEx.
Thank you, Andrew. Can you put the my slide? FedEx slide. I gave you thumb drive today, just 5 minutes ago. Just let me check whether. Okay, thank you for your patience. Welcome to FedEx section. I will give you first the brief introduction about what is FedEx. Okay, so you probably have heard of FedEx, but you probably don't know what exactly this means. About FedEx? Well, FedEx is a collaborative forum within which learned societies or associations involved in engineering with, on, or in geomaterials can meet and interact. Very complicated, right? So we have 4 member societies: ISSMGE, ISRM, IAEG, and IGS. You all know that. History is quite interesting. In 2004, 3 member societies presidents met and had an agreement that joint task force having 3 member societies come together in 2004. Just signed the joint task force the agreement. And then 2007, ISSMG and ISRM, IAEG, as a founding members, created FedEx. And 2008, inaugural meeting was held in London. That was a very historic event. Later, in 2014, I just joined. So now we have 4 member societies as a FedEx member society. We have board members, the 3 from each member societies: president, and immediate past president, and secretary general. So 12 are the board members. We have 4 joint technical committee: JTC1, natural slopes and landslide, and managed by ISSMGE. You can see the name of the chair. JTC2, representation of geoengineering data, managed by ISRM. JTC3, education and training, managed by IAEG. And newly created JTC4, environmental and geoengineering sustainability, managed by IGS. So what are the goals? To facilitate interaction among the member societies and to explore opportunities in promoting common interest and to provide a unified response to common issues through collective action. These are the goals of FedEx. And what about the goals of JTCs, Joint Technical Committees? To increase interaction among the members. Okay? We are dealing with the same material, but sometimes we are not on the same page. We want to share different views on a variety of technical subjects to narrow the gap and to learn from each other. These are the main goals of joint technical activities. So FedEx board meets every year, once a year, in person. but many online meetings. This year, we had a FedEx board meeting in Goa. Very nice venue, probably the best venue that we have had. Thank you for the organizer, Indian Geotechnical Society. You see the pictures. And JTCs also having a lot of activities. And next year, JTC 1 and JTC 3 will have joint workshop in New Zealand. And JTC 2 also is doing a lot of work. And they have their own conference, ICITG, International Conference of Information Technology and Geoengineering. Last year we had in Golden, Colorado, US. Next year we will have 6th ICTIG in Graz, Austria. And JTC 4, they are doing very diligently to get a white paper on sustainable geoengineering. So JTCs are working very hard, and the board members are supporting them also very hard. This is a special thing, introducing FedEx Mega Conference. Well, probably some of you know that we had Geoengineering 2000 as a mega conference. That was the name of the conference was first International Conference on Geotechnical and Geological Engineering, organized by Australian Geotechnical Society with initiatives by ISSMG past president, Professor Jamalowski. Successfully held in Melbourne in November, and that event was jointly supported by 3 members. That was before FedEx was created, ISSMG and ISRM, IAEG. And during the conference, a lot of geotechnical and geological engineering themes were covered. Now, second conference, that name may change, but the FedEx board has decided to hold the second conference of its kind in the year 2030. Currently in the almost final planning stage, and the venue and program details will be finalized by next year. So we have task force led by Dr. Sam Allen from IGS, and we really look forward to that. Now this is FedEx section. This is also a historic day. This is first FedEx section we never had. We talked about having this session for a long time, but this is the first session. You are seeing landslide. Actually, they occurred in Korea a long time ago, and the bottom one recently. So these are happening everywhere, right? So there are a lot of geoengineering problems related to climate change, so we have to do something. We have to provide mitigation measures. So today's session we'll talk about, you cannot draw a conclusion, but I hope that this session will shed a light on what we have to do as geoengineers. With that, I'll call Andrew to moderate this session. Thank you very much.
Thanks very much, Joseph. So at this panel discussion this afternoon, we've got the chair of FedEx, and we've got the 4 presidents of the sister societies. So we've got a really good lineup here, and we've got some pre-prepared questions that we're going to throw to them, and let's see what they have to say about some of the key issues that are facing geotechnical engineers. So the first question is that the world's facing a climate emergency. So, Sam, what role should FedEx play in response to that?
Well, very good question, Andrew. I'd like everyone to consider this question through the lens of policy. So much of the engineering world responds to infrastructure in accordance with building codes, right? Building codes. And the previous speaker just held up a standard, Indian standard, to talk about the policies and the practices that go into that design. Well, all of our designs from the geoengineering community are being revisited. Why are they being revisited? Because the Earth is changing. Our brethren in the climatology industries are giving us new data that our designs need to be informed by. So I think from a policy generation standpoint, us, the family of geoengineering, needs to speak to the regulatory community, the codified community that brings these standards to bear. How much more drainage do we need to keep that soil mass drained? What kind of materials need to be prioritized to lower the carbon footprint of an infrastructure element? So this has to be standardized, and you are the voice that is needed to bring this to bear. So I would start there, Andrew. I would start with FedEx has the unique opportunity as a global family of engineering societies to capture the attention of that policy group, of that governance of design. So let's start there.
Okay. Vasilis, what would an engineering geologist say?
Okay. Thank you, Andrew. And first of all, thank you very much for the hospitality. It's fantastic. We all love the people, the culture, the food, and congratulations to all of them. We wanted to share that. So in order to build on what Sam said, so FedEx has a unique, let's say, a unique power, having a full spectrum of all geoengineering specialties, expertise, from geology to geotechnical engineering to geoenvironmental engineering. So this collective technical knowledge translated to global impact and to policymakers is very powerful. So I would say three main important roles. First of all is that we coordinate now with each other, and we have a common voice, which is very important. We have a common, it's not just a message out there. So first of that. The second one is that we bridge science and policy, like you said. So from the education point of view to the policy and the experience and all these different kind of expertise from geology. So these, for example, geological point of view, these are rarely acts of nature. They're always related with how is the ground and how the ground works. So we start from that. And then we continue with putting numbers behind that, realistic model, and starting communicating all our results to decision-making process. And the third one is very also important, is how we embrace this geoengineering information and knowledge through the interface. So FedEx facilitates the interface between technical associations and more international bodies, policy makers, and we see that geoengineering in all sister society perspective is represented appropriately. So this is what FedEx can do, can be a voice, not just the goal to unify one message, but to be, let's say, from the science point of view, the more representative, true voice of the ground from the science-based relay.
Okay, thanks. So the problems that we face mean that presumably education has to evolve to prepare for the climate-intensified risk landscape. So, Serquan, How's that going to happen? How is education going to evolve?
Thank you. Before I start, on behalf of ISRM, I would like to thank ISSMGE and the organizing committee of Geotech Asia 2025 for allowing us this wonderful opportunity of FedEx session. Geodisasters such as landslides, rockfall sinkholes, collapses are not rare in many places in the world. They are increasing in frequency and intensity under the combined effect of climate change, urban expansion, and deep resource development. We have multi-phase, multi-hazard problems from shallow slope failure in soft rocks to deep rock instability in subsurface energy systems. These are not isolated engineering problems. They are systematic and coupled phenomena that demands a unified and multidisciplinary approach. So ISRM recognized these challenges as not only scientific issue, but also societal mission. So we have different strategies, but we have a focus on collaboration, education, and technology development. So ISRM is reinforcing its collaboration with the FedEx sister societies to promote an integrated and unified view of geohazard and geosafety. So we have activities through commissions and joint technical committees. ISRM is also focusing on education and knowledge dissemination through online lectures, book series, suggested methods and their videos, young member webinar, and rock mechanics course. They are providing the ways to transfer knowledge. So we also value high the outputs from the young group members and then showcase their achievements through some award programs. We are in the area of digital information and digital transformation, and we should take the full advantage of integrated AI, remote sensing, and data-driven systems to move from reactive response to proactive prevention to disasters. I also like to note that ISRM plays an important role in addressing major issues associated with the energy transition, including geothermal energy, hydropower, pumped storage hydropower, oil storage, compressed air storage, hydrogen storage, CCS, etc. In summary, ISRM envisions a world where rock mechanics knowledge will safeguard human life and infrastructure. I hope we can work together for that, our discipline of geoengineering. Continue to support. Thank you.
Can I?
Okay, well, very thorough answer, but Mark, could you add to that?
I like to give my opinion about that because you said education to face this climate change is, in my opinion, so far, we are facing what is given in terms of deterministic stuff, loads, and we are not prepared as engineers to face climate change, really. We have the technology, but we are not prepared. So the universities and all the academicians here should be careful in adding to the engineering courses climate science, how to study the weather, how to predict what will happen, not only design for a 100-year flood, but design for a projected 50-year chain of events. It may not be the 100-year flood max that is a critical thing. So we have to study a nonlinear process. A little bit of rain with a wildfire can create a more critical landslide, for example. That's my opinion. So we should be ready to expand again rather than get a PhD and laterally loaded piles. It should be expanding.
Okay. Quick comment from Chung Si.
Yeah, I'd like to add, as a university professor, the research in that area is also important, but basic education to undergraduate students are also very important. So as I mentioned during my keynote lecture, the opening speech, buildings and construction accounts for 38% of CO2 emissions globally. So we have a responsibility to do something, right? So during the education, we have to teach them. Probably we can hire other expertise, but we have to teach them, let them know what kind of carbon dioxide, greenhouse gas emissions can come from a certain, for example, geotechnical solutions. For example, IGS is very diligent and instrumental in developing and providing the members, for example, as an educational tool for life cycle assessment of geosynthetic solutions. I think we have to have the number, right? What are the greenhouse gas emissions from particular geotechnical solutions? So we have to provide some tools to the students so that they can have some kind of taste of what is sustainability and how that is related to climate change. I think that is a very important aspect.
Okay.
So,
Thanks.
to make it short, we should shift quicker from a deterministic safety factor approach to a more probability and reliability based designs.
Risk.
This will take care easier for these climate changes.
So, I want to move on because otherwise we'll run out of time. But Sam, I'll let you come in there, and I'm going to ask you. I think that feeds into this. What are the realistic roles for digital tools in the near future associated with this?
Yes, well, this is a budding industry, actually. Even if we narrow our lens to carbon calculators, for example, there are many, many databases, many platforms from which one could exercise the practice of determining the carbon footprint of an infrastructure element. I think this is another opportunity for the JTCs within the FedEx group to parse those platforms and to provide a global voice for the best, to hold them to the highest quality. And this is very important. Just regarding education, so much of the impact, good or bad, in terms of navigating that non-linear environment that we're now designing in, with global weather patterns changing, superstorms, unstable grounds based on previous practice, the opportunity to respond to that successfully is at the very beginning of a project, right? So if we could plot the impact, Andrew, versus time, all of the impact, the good impact that the designer can have regarding choice of materials and design is at the very beginning of the project. You just saw a movie of the after effects of design, right? When we have a hillslide sliding over a road, that design has to change, right? Based on new information about weather. So I think that it has to be informed by highest quality standard digital tools, environmental product declarations that are alive and well in Europe, need to spread all over the globe in terms of materials that we are working with, construction materials, and I think FedEx has a role to play in defining what the best elements are.
Okay, Chung-Sik, can you add something?
I think Sam made a very important point. I'd like to go into more specific way to use digital tools. During my keynote lecture, I showed you how we can use digital tools to help designers and to expedite the routine design. I think digital tools cannot solve every problems, but it can help us to make a decision. Okay. For example, we have many areas with a landslide caused by heavy rainfall. So we can collect all the data, the weather data, geological data, local engineering related data, and we can relate those information to landslide patterns. Okay. Once we collect all the data, we can use so-called deep learning, right? And deep learning is not only provide a predictive tool, but also it can identify what are the important factors so that we can make decisions. So digital tools, we are using it without hand phone, without mobile phone, we cannot do anything, right? So I think that the time has come to use digital tools more effectively to make a decision. I think those tools can help us to make decision for disaster prevention and providing an early warning system. I think we have to use that tool more proactively so that we can make this society, this community safer.
Okay. Mark, you can say something quick? No? Okay. Vasilis, we've got to move. Things have got to change. So how can we convert the existing guidance into everyday practice? How are things going to change?
So I have to say that first of all, when we have a geodisaster, immediately then we need to communicate to the people first, to the society, but also to the policymakers, and discuss why we have that failure. So this is first very, very important. Very important to say why this disaster happened, why it happened there, and under what circumstances, and how we analyze that is then the second step in decision making. So imagine a federation when you can click in a disaster in an area and you say, okay, I select immediately a certain series of maps. So you have some specialists from the geological community. You have also some specialists from the geotechnical community in the area about that disaster, if it is earthquake-driven or after a heavy rainfall. So immediately this connection is being made by the local people together with the international expertise. It gets you immediately a series of data to start understanding why and how this started. But I wanted to point out something that it is very important about the smart technology we're using, the tools we're using, and with the codes. So we have the codes, we have also the best international practice. So we have also that. We have the local practice. We have the limitations. But I think that always would be a decision-making process based in the engineering judgment. What we say engineering judgment is very, very important. So I think that geological engineering and geotechnical engineering judgment will be always important. Yes, we will have very fast data many times, but at the end, in order to make a decision, many times with a fast-track process, we need a kind of judgment. And this judgment comes with very good engineering and education, but also it comes with very good expertise through the field, through the works. So there you need some people in order to, yes, prioritize, let's say, where we will have the ground investigation, what kind of analysis, because we will have all the pressure in our hands to take a decision. So we wouldn't have all the time, to make numerous analyses many times. We have very limited time, sometimes limited data. So we need to prioritize also through that experience. So this is something that we need to take care also through the federation, through webinars, through common joint, conferences, educating in real project, real case studies, apart from the smart technologies. I'm sure the young people will eventually learn about that. They are so fascinated. But the engineering judgment and the expertise and how the ground works and to know where and how to support that is crucial.
Okay, thank you. Mark, this is really the last question. Climate change makes compound hazards like wildfire and debris flows, and rain and heat, all the more complicated. So, are we prepared as geoengineers?
Let me reply with a question, and I'm going to move to some philosophical thoughts rather than geoengineering. If all the people here coming from, let's say, 30 countries, all these engineers with us, each one of you is the president of the country, not the engineers. You are the decision maker. Trust me, we wouldn't be here. The problem which is floating between all the replies is that we are trying our best to solve what humans are doing bad. So we as humans, we destroy the jungle, we destroy the environment, and then we are asked as engineers to be part of it by building bigger bridges, high-rise towers, bigger stuff, and we are ruining. And then we come back and fix ourselves with, oh, let's watch the CO2 footprint, and then all this should change. And I don't know when, but I listened to my daughter, for example, with the RRR principle, reduce before recycling, reuse before recycling. So we should start thinking about those events coming together, compounding. We are creating them. So let's go back to the roots, in other words, and stop pretending that or showing off that we did the widest, biggest highway. We should say we reused the same highway and did a tunnel underneath to save the environment. The thinking should start from here. And I keep preaching, and that's why we have geo-environmental for every one of us as a society. We should think even beyond and push ourselves to become politicians, because the decision at the end is not us. So, like it was mentioned, and the judgment that was mentioned is also judging all these mistakes to, look in between the lines and take the decision that is suitable for a better future, but not the best future. So that's my reply.
Okay. Vasilis, have you got something to add? No? Has anybody on the panel got some last words they'd like to add?
I want to, since we have some time, tell you about the GeoWeb, since Professor Pierre Delage are here and Dr. Daniela. If you have the mic, just tell the audience what we are trying to do and excite all the societies to join.
Yes, thank you, Mark and Daniela. Very briefly, GeoEngineer Without Barrier was started upon your ideas in Sydney 3 years ago, and we have been doing various missions. The membership is around 70% for the moment, including Nilima here. Emanta Zarika was recently made a mission for the Japanese Geotechnical Society in Myanmar. We also have the former chairman of GTC1, Picarelli, and other ranking lecturers. So we have a very strong group, and there have been some missions already performed for a rock slope in Papua New Guinea, heavy rain and slopes in Brazil, dams failure in Libya, and more recently we were called by the municipality of La Paz in Bolivia to make sure that what they were doing with very risky slopes were correct. So we learned some lessons from this. Some of these is that some of countries that really need to be helped not necessarily provide the safety. There have been problems in Sudan, but we could not go there. In Papua New Guinea, our members were escorted by the army from Australia and New Zealand. our expert in Libya was supported by UNDR, and we are a member of United Nations Disaster Risk Mitigation Office. Also, we have to learn from well-organized countries who face correctly some geodisaster, like Taiwan with a recent earthquake. So this is the thing. And I finish, another important conclusion is that local contacts are really important. And this was the case in Brazil. We knew people, so we were invited. And what we observed...
we are officially registered
Yeah.
Geoengineers Without Borders with the United Nations.
Yeah, UNDR, we made
disaster
reduction, United Nations Disaster Reduction Office, UNDR.
So I'm officially inviting FedEx to join. It's already named Geoengineers, so we can all fit.
Okay.
So we will send.
All right. Andrew, I think, Andrew, we have questions from the floor. I think we have to take it.
Thank you, Pierre.
Please.
I think we have a very distinguished panel here. I think one of the topmost I have seen in any of the conferences. Very relevant topic. Thank you very much for FedIGS as well as the Geotech Asia. My question is two-part. One is to continue the question of Andrew. What he writes, multi-hazard is becoming common now. Multi-hazard happening simultaneously. So how do we design the infrastructure for multi-hazard happening simultaneously, like cyclones, landslides, fire, all kinds of combinations? How do we design the structure, and should we really design? That's the first part of the question. Second part of the question is very big countries, I don't want to take any name, but we're already disclaiming there is no climate change. We have heard the leaders of the countries are saying. In such a scenario, how very distinguished people sitting here, what would be your reaction to such a statement that climate change is not real? Thank you very much.
I think so. How do we do this? Right. Well, again, this is, I'm a good spokesman for this from the USA. Mother Earth could care less what our policymakers are doing, could care less. Planet Earth is doing what it will do. That's where we start, right? As an engineering society, it's our jobs to respond to reality, not imaginative denials, right? So that's number one. Number two, I think that in the context of design, I think we the word sustainability, for example, it's not just about carbon footprint. The engineering judgment, perfect term, right? It's not just about counting carbon, it's also about social justice. It's also about efficiencies. When you were in college, you learned about materials and the performance of materials. And then you graduated and learned very quickly that everything runs around economic reality. Well, now we're going from performance to economics to resilience to sustainability. And it's that education and it's the communication all the way from the student to the governor, to the policymaker. So we are challenged to do that because we went to engineering school, not to communication school, right? But we have to do it. The voice, the learned voice of FedEx community must be shared to the highest level of policy making, of decision making. So I'll leave it there.
We are very nearly out of time. Just one quick
well,
comment.
actually, I respond to that, and also I close the session at the same time. Well, I don't think it is important whether we believe climate change or not. We are already experiencing it. For example, in Korea, well, when I was very young, we had 4 distinct seasons: spring, summer, fall, and winter. Now, almost spring and fall are gone, right? So we are already experiencing. And we are getting a lot of rain. 10 years ago, 15 years ago, we had annual precipitation is about 1,300. Now, 1,500, 1,700. So whether you believe or believe not, the climate change, it doesn't matter. We are experiencing. In terms of design, I think we have to do something about, for example, heavy rainfall. Now we're assuming when we design retaining wall, if we use free draining material and don't consider water pressure, right? That doesn't work, you know? Under the current heavy rainfall, that doesn't work. We have to include the rainfall intensity during the design. I don't know when that can happen, but something has to be done. In that way, we can build a safer infrastructure. That is my personal, not FedEx opinion, but personal opinion. I think everybody agrees that. Because the time's up, I'd like to close this session. You want to say something?
One thing,
Sure.
yes,
Yeah.
yes. We are here geoengineers and thinking in that specialty, how to face the future. Just a small fact that in 50 years it will be impossible for many countries to survive outside the air conditioning. It's rising faster, so the idea of we should reverse the process and save nature and jungle should really be encrusted within us. Saudi Arabia, Kuwait, Qatar will no longer be able to have enough energy to cool their buildings and areas in 50 years if it keeps going at this rate. So it is a major thing. Thank you for having this session, and I will let you, President.
Well, as I mentioned, this is the historic session, FedEx session, first session that we ever had. And we had 45 minutes, and time was not enough. And also we can make a conclusion or draw whatever the conclusion, but I think this was very important. This is a start. We confirmed that we are on the same page, right? I think this is the beginning. I think the better things will come in the coming days. And I really appreciate the organizing committee and Indian Geotechnical Society for having us here, having FedEx section, and your hospitality and everything. We really appreciate, and we will remember your hospitality forever. Thank you very much. I close this session. Thank you.
Thank you.
Kindly be seated, sirs. We have not finished as yet. Request Dr. Anil Joseph to be on the stage to help us present mementos to the distinguished members. I also invite onto stage Professor Ashish Juneja and Dr. Dasaka Murthy. To present the memento to the moderator of this session, Andrew McNamara, I invite Dr. Anil Joseph. Requesting Professor Dasaka Murthy to hand over the memento to Professor Chung Sik Yu. Request Dr. Anil Joseph to present the memento to Dr. Mark Laws. Requesting Professor Ashish Juneja to present the memento to Professor Sequan Cheon. Professor Desaka Murthy to present the memento to Professor Vasilis Merinos. Request Professor Dr. Anil Joseph to present the memento to Dr. Samuel R. Allen. I request all the dignitaries to please be on stage. We have one more important thing to be carried out. I request all the distinguished guests to be on the stage. We will now release a souvenir of Geotech Asia 2025. I request Dr. Mark Bellows to do the honors. The people who work behind releasing the souvenir requires a loud round of applause, please. Thank you all. Thank you, sirs. I request Dr. Anil Joseph to remain on stage. Thank you all. And I would now invite Dr. T.G. Sitaram onto the stage for a special announcement.
Thank you, Dr. Anil Joseph. I'll keep it very brief. Now, as you all know now, India has become the fourth largest economy in GDP. And large number of engineering graduates are coming out from India. They are everywhere. So I, as the head of the All India Council for Technical Education, have penned a book on unlocking the potential of technical education to shape India's future. This is focused to India, but I thought today I'll present this to Anil Joseph. It talks about innovation, growth, and inclusion. And this is available in Amazon already, in Amazon bookstore. So this is. I've actually, as a head of the technical education for the country, I've addressed close to 1 million students, more than 200 convocations, and that I brought it out as a book on what are the issues, challenges. So this is basically to inspire the young minds to embrace the research and innovation. Now we have made research and innovation mandatory in most of the engineering colleges. That means we encourage them to start asking questions, think about and solving rather than just teaching. So this is one change what we have witnessed in India today. So more than 3,000 institutions have started from 2 years back on innovation councils as well as research and development cells. So to focus on research and innovation. This book basically covers that topic. Thank you.
Thank you, sir. Thank you. With that, we come to the close of the technical sessions of day 1. We have a welcome reception arranged for all the delegates from 7 p.m. to 8 p.m., inviting you all for the welcome reception on the rooftop. I would also like to request all the speakers of tomorrow to kindly give your presentations so that we have day 2 run smoothly. So requesting all the presenters, the invited speakers, as well as the speakers of parallel sessions to hand over your presentations at the respective consoles, either today or tomorrow morning, please. We have 3 invited lectures, 4 keynote lectures, a panel discussion, and 6 parallel sessions tomorrow, the day 2 of Geotech Asia 2025. Thank you all, and we look forward to seeing you all at the welcome reception to commence from 7 p.m. at the rooftop. Thank you all once again, and reminding the speakers of tomorrow to kindly hand over the presentations at least by 8:30 at the respective halls. Thank you all. Have a great evening.